In this video, I'm going to calculate the coefficient of variation. I'm going to do it for two different sets. So I have set A, and those data values are given in column A, and set B in column B. And the question here is determine which data set A or set B, has more variation. Now, the first thing to point out is that there is no Excel function for coefficient of variation, but that's not a big deal. The formula for coefficient of variation, so let's say CV for coefficient of variation, well, this is equal to the standard deviation divided by the mean. And that's normally given as a percentage, so that will give us some decimal value, and we'll have to multiply this by 100%. All right, and we're using the sample standard deviation and the sample mean because we have two samples here. If you're working with populations of data, you would use sigma over mu times 100. Right, but we have sample data here. All right, so this means that to calculate the coefficient of variation, we need to calculate the standard deviation and the mean of each set. So over here, let me make this a different color. Over here in these four cells is where we're going to calculate the mean and the standard deviation of, that was the text color. I'm going to calculate the mean and the standard deviation of each set in these four blue cells here. Okay, so we're going to be using two Excel functions, the function for mean, so x bar, remember mean is or at least the arithmetic mean is the average. So the Excel function is equal average, and then in parentheses, the location of the data. And the location of the data is going to be either A2 through A21 for set A or B2 through B21 for set B. And the Excel function for the standard deviation, at least the sample standard deviation, is STDEV for standard deviation dot S, because it's the sample. And remember, if you're using a calculator, the formulas for sample standard deviation and population standard deviation are slightly different. So we want to make sure in Excel we're using the sample version of the standard deviation, and then in parentheses the location of our data. Okay, so once we have those two numbers, we could divide them, and that will give us the coefficient of variation. All right, so let's look at set A. So here in cell D2, I'm going to type in equal average, open parentheses, and the data. So you could use the mouse to highlight A2 through A21, or you could type in manually A2 colon A21, either way. So that will give us the mean of set A. All right, so we have a mean of 6. And for the standard deviation of set A, we're going to use that standard deviation formula, equal STDEV dot S, open the parentheses, and the location of the data, which is again A2 through A21. All right, so set A has a mean of 6 and a standard deviation of 3. Now, this mean of 6 is referring only to set A, has nothing to do with set B, and this standard deviation of 3 is referring to set A, has nothing to do with set B. Okay, so let's do the same thing for set B. The mean, sample mean, would be equal average, parentheses, location of the data. Okay, so set B looks like there's an average or a sample mean of 45. And the standard deviation equal STDEV dot S. That's our sample standard deviation function in Excel. And let's highlight the data. So now we have B2 through B21. And set B has a standard deviation of 20. Now, you cannot use these numbers to determine which set has more variation. It's comparing apples to oranges. Even though the set B has a higher standard deviation, Well, that 20.7 is relative to the numbers in set B. And that smaller standard deviation of 3 is relative to the numbers in set A. So what we're going to do is, now we're going to calculate the coefficient of variation for each set. And the coefficient of variation is equal to, so I'll type equal, the standard deviation divided by the mean. And you could multiply that by 100, or we could just change it to percentage, either way. Now you see 50.15%. You would say, okay, well, 3 divided by 6 is exactly 0.5, not where'd the 0.15 come from. Remember, these are just rounded numbers. So if I increase the decimal, so this is not exactly 3. There's 3 and a little more than 3 there. Okay, so that's why we don't get exactly 0.5 or 50%. Okay, so let's look at set B. The coefficient of variation equals the standard deviation divided by the mean. And let's convert that to a percentage. So set B has a much larger standard deviation, but there's larger numbers in set B. So to compare these two sets, when you're comparing two sets that have different sample means, in this case, very different sample means, a 6 and a 45, you cannot compare the standard deviations of the two sets. That's what the coefficient of variation is for. The coefficient of variation, there's really no point in calculating it for only one set. The coefficient of variation is used to compare two sets, 2 or more sets. So it's used to compare multiple sets of data and determine which set has more variation relative to the other sets. All right, that does it for coefficient of variation. I took about 7 minutes to do it, but it's only maybe 15, 20 seconds if you're just cranking out these numbers on Excel. And this is, obviously this is a much, much longer problem if you are using a handheld calculator and paper and pencil. Okay, that does it for this video. Hope it was helpful.